But yeah, so again, I'm head of DevRel at Dremio. Here, again, I've basically gotten to work as a developer in a past life. I've gotten to also be a contributor to several different books. Apache Iceberg, the definitive guide, Apache Polaris, the definitive guide. Both of those books you can get at lunch today. We'll be doing a book signing, so you can get a free copy of the books. But if you want a digital copy, you can scan this QR code. I also did a collaboration with several other companies. So between Dremio, MinIO, PuppyGraph, Confluent, and 5chan, we wrote this Apache Iceberg Digest Volume 1, where kind of each company kind of wrote about their sort of expertise. I did a chapter based on I did the catalog chapter, the Iceberg migration chapter, and the what is Iceberg chapter in that book. So all of those can be gotten for free by scanning that QR code. And my newest book, which I'm just about wrapping up, is Architecting an Iceberg Lakehouse. I generally raffle that off at every event I go to. So if you want to enter that raffle, that's a QR code for that. And then you'll get an email if you win saying, hey, here's your coupon code to get a free copy. Okay. So now that we've established that I spend a lot of time thinking about the Lakehouse, let's talk about the Lakehouse. Okay, so what I want to do in this presentation is, one, talk about where Iceberg is now and where it's going in the future. So, hey, what just changed with Iceberg v3 and what's coming up in Iceberg v4 and what kind of early discussions are already happening. But before we do that, I want to make sure I always level set. So I always just like to reestablish what is a data lakehouse, what is Iceberg, why are we talking about this? So again, a data lakehouse is just a different data paradigm. But when we think about the way we work with data in the past, we typically work with databases and data warehouses. We love these systems because they would abstract away a bunch of things for us, like how the data is stored, how do we track the individual tables in that data system, how do we track which tables are in the system and govern them, and then how do we actually process a query? Like how do I actually ask a question using something like SQL and get that answer back from this data? All of that would just be kind of happen behind the scenes, and I would just worry about interacting with the system. Wonderful. Whether we're talking about row-based data, if we're talking about like an OLTP system like a Postgres, or if we're talking about analytical columnar-based data sets, if we think about like OLAP systems or data warehouses like a Snowflake or a Redshift. Okay, the problem with this though is that every database, every data warehouse does all this stuff differently. So what ends up happening is that everybody kind of creates what you call a data silo, where basically I have data here that you need, but your system doesn't talk to it, and they have data you need, and your system doesn't talk to it. And you end up with all this, having to do all this moving data back and forth to deal with these data silos. So the dream is like, wouldn't it be nice if we just had one place where everyone just kind of had access to the data? So we tried doing this with data lakes, and we would use things like Hadoop and object storage and just pour a bunch of Parquet files and a bunch of images and text, and that's good, okay? It gives us one place where all the data can just be. The problem is that initially it's just file storage. So your systems, which are in the way you do analytics, you typically think tables, not 1,000 Parquet files. You think, hey, there's my sales data set, where's my orders data set? So, and this doesn't have the same kind of guarantees when you came to making changes to those data sets and a variety of other sort of friction points. So data lakes were great, but for especially working with our like structured data sets, there was something missing. So when we take a look at the data lake, we have our storage where we put the data. We have processing tools like Dremio, Athena, and other tools that can query the data lake, but there are some layers that were missing when we think about database and data warehouses. So what happens if we bring those layers back? We get a data lakehouse. I just take that storage and processing layer, and we add in a table format like Apache Iceberg that tells us, hey, these files are individual tables, and a catalog that tracks those tables like Apache Polaris that tracks those tables and determines who has access to them. And now my data lake does feel like a data warehouse, thus a data lake house. Okay, wonderful. So that's kind of where we got to. That's where we are today. And now as you saw our announcements, Dremio is constantly trying to be at the forefront of making it easier to do this whole data lakehouse thing. And I'll come back to that in a little bit. But essentially the end result is you should just have to move your data into this data lakehouse, and no matter what tool every team wants to use, they can use tools. So no longer is there have to be this political fight between departments in the company about which tool to use. You have your data in the data lakehouse, it's governed in one place, and everyone uses their preferred tools at the end. Okay, so get a happy story. But again, one of the key pieces to this is the table format, Apache Iceberg. Okay, and at its most simplest, Apache Iceberg is a bunch of metadata. So again, like the original sort of Apache Iceberg architectural diagram is this, where basically you have your catalog that allows you to know which tables exist, and all your files with the actual data. In between them, you have these 3 layers of metadata that tell engines the schema of the table, how the table is partitioned, what are the different files located within that table. And using the statistics in those files, I can kind of create what's called a scan plan. So there might be 1,000 files in the table, but using the metadata, I can determine I only need to scan 3 of them, allowing me to scan the data much faster. But this has gotten more complicated over time. In good ways, in ways that enhance the format. Okay? So when we think about the evolution of Iceberg, you had Iceberg v1 that kind of introduced that basic metadata structure. But in that initial stage, you only had what's called copy and write. Okay? So basically that meant anytime, if I updated one record in a file that had 10,000 records, I have to rewrite that entire file just to make that update in the next snapshot. So in order to kind of be able to do faster updates, they introduced the concept in v2 of deletion of delete files. And you had 2 types of delete files. You had position deletes that would say, hey, this file's going to tell you, don't rewrite the whole file. Just know that when you do read the file later on, ignore this row or ignore this specific row. And it'll tell you the specific row in that file to ignore. You also had equality deletes, which the idea is that to do a position delete, I would actually have to go read the Parquet file to know exactly where the ignored record is. So I could actually give you the position of where it is. But that's still a thing I have to do, which that's still like time I had to take during the write. So for like really, really fast writing, they came up with this idea of quality deletes. How about this? We're just going to put some information that you can use to reconcile which records to ignore. So maybe like, hey, if this data has like an ID field, I can just say, hey, ignore any records that have this ID. So instead of having to go read the file and determine its position, I can just write the value and ignore it at read time. And that all worked really well. You were able to do much more faster updates. You now have this pattern called merge on read, where you reconcile these changes when you read the table. But it could always be better, right? We always want to improve on these things. So in v3, one of the major changes was things like deletion vectors. We also added like lineage tracking, default column values, a bunch of other things I'm going to be talking about a little bit more in depth in a moment. But then we're going to go even further because you're already starting to see discussions about v4 where you're talking about things like relative file paths, single file commits. So remember, there was those 3 layers of metadata in that metadata structure. What if that could all just be one file? How much faster could a commit happen if that's the case? So these discussions are going on now about what the next version of it's going to look like. Now keep in mind, right now the normal is still v2. v3 only was ratified or approved by the Apache Iceberg project a few months ago. So once the spec has been updated, that means every tool has to now implement those changes. So little by little, every tool is now adopting v3 and building v3 features into their tooling. So I just want to caveat that out there saying probably for like the next at least like 6-ish months, v2 is still going to be your day-to-day normal, okay? I wouldn't rush to upgrading your tables to v3 too early because you might end up having issues with things that haven't been fully implemented into all your tooling yet, okay? But that's there. And then the discussions for v4 will happen in probably, what, like 18 months from now? That'll get ratified, and then you have to wait like another 6 months for, so just like timelines, like some of these features will sound cool, but I don't want to like make you think that tomorrow you'll be able to like do some of these things, okay? Okay, cool. So again, we have this evolution of Iceberg tables across these different specs. And these are nice innovation drivers because everyone wants things that sort of benefit their particular workloads. So then basically there's this urgency between versions for everyone to kind of have these discussions and push the format in new directions. So if you don't already subscribe to the Iceberg dev list, you should, or you can follow me on LinkedIn and I do a summary of it every week. So yes, a benefit to follow me on LinkedIn. Okay, but some of the changes that you see in v3, one was deletion vectors. So the idea is this: instead of having all these like delete files, and typically you would have a lot of delete files, which means you're opening up many files to reconcile these deletes depending on how many updates you made and across how many files you made. The idea of a deletion vector is that you're going to store all that information about which records and which to ignore in a binary format. In the Iceberg spec, there's this thing called a puffin file. It's like basically a place where you can store binary blobs where you can maybe put an index in there, you can put whatnot. Right now it's mainly used for like data sketches and now for deletion vectors, okay? Cool. So now the idea there is it's going to be a much faster way to go find all those different records that I need to ignore when I'm reading a merge on read table for v3. So it's just improving that whole merge on read thing, and I'm sure there'll be improvements to that even further in v4. Row level lineage. Big thing is trying to know, hey, where did all this data come from, right? Because it's hard to troubleshoot problems with your data pipelines if I don't know where the changes happened. So being able to know sort of like, hey, this row was derived from this other row. Now there's a row ID field that can help kind of see how those changes happen over time. Default column values. Okay, one of the great things about having a table format is you can do schema evolution. Problem is, what happens if you add a column and you have all these records from the past that didn't have that column? How do I treat, are they just null? Well, now you can specify a default column value to address that problem, making it easier to avoid like the null issues when you add columns. New data types. This is probably everyone's most like, generally what people get really excited about, particularly like the variant data type. Because before you did have a JSON data type where you could store JSON in your Iceberg tables, but again, JSON is just a text string. Okay, so it's encoded as text, and you got to parse the text, and you got to go traverse the data structure. That can all take a lot of time. But with variant, you do this extra thing called shredding. Basically allows it to traverse that structure much faster and be able to break it down in a way in the data in a way that's just faster. Okay, and that took a while to do because it was like a couple different versions of variant that were being discussed. Like Spark had one version, Snowflake had a different version, and then they had to kind of hash out how they were going to do that, and they ended up all agreeing. Also, big thing was geometry and geography data types. Okay, so now you can do geospatial stuff with Iceberg. And again, one of the key things about all of these, and this is one of the nice things about like the greater community kind of collaboration, because in order to have these data types, you can't just say, hey, we're going to have these data types, because the data isn't stored in Iceberg, data is stored in Parquet. So the big thing is that Parquet has to support these data types. So across the different table formats, there's a lot of cooperation trying to get these data types into Parquet, so that way the table formats can support them. So it's always fun. That's so also good to follow Parquet, because when Parquet supports a data type, then it means all these table formats can support the data type. So fun stuff. In the early stages of doing data encryption. Okay, always a big question is sort of like, you have your data encrypted, but how are my other engines supposed to know what my encryption keys are? Okay, so basically, yes, I have Iceberg tables and Iceberg's interoperable, but maybe my encryption isn't portable. So the idea of being able to store encryption keys in your metadata, and then eventually being able to encrypt your metadata, not just your data files, but also your metadata files, are things that are kind of slowly evolving into the Iceberg spec. So that's all v3. So v3 kind of laid the groundwork for all of that. But then the question becomes, what comes next? And so right now, again, this is only a couple months that we've started having a v4 discussion. So these are just early proposals. There'll be many more proposals to come. And not every proposal will end up making it to the final spec changes. For example, one of the things that I don't mention here, but that is still being discussed, is materialized views. And that was being discussed before v3 was ratified. And it's still being discussed because there's a lot of moving parts. Okay, how do you know when to refresh a materialized view? How should you physically represent a materialized view? It's very interesting discussion. So if you really enjoy just geeking out about database internals, very fun to read. But there's a lot of other things to do. Okay, deletion vectors. Okay, so again, here I'm just talking about sort of where v3 support is now. Okay, as far as you're starting to start seeing some of the early stages of v3 support in Spark already. So you can see deletion vectors are supported in Spark now, like row ID. Default values are supported for table creation. Okay, the type support that should already be in there, at least in the Java libraries. But again, pretty much beyond that, and also multi-column transforms was another thing that was new in v3, which is really cool. So basically, traditionally, what you would do is you would have these transforms you could do for partitioning, and you'd be able to target one column, so bucket based on this one column. But now you'll be able to do potentially multi-column transforms. So imagine being able to do hey, I want to bucket this table into 16 buckets based on 2 columns. Okay, that would open up some new ways to sort of balance your partitionings out, or partition your data in interesting ways. Okay, but again, bottom line is anything that improves Iceberg performance are going to reduce your infrastructure costs. Okay, having encryption is going to improve data governance. Okay, faster time, again, that's basically the same thing, fast is fast, faster time to value. But modern data type support is also going to just help you be able to type your data better, which also improves performance, but also helps put the guardrails in there to ask better questions and can provide context, especially to AI, because if AI understands what the data types of your data better, more granularly, it can better sort of infer things. Okay, and then again, just more security stuff. Security is probably some of the other big discussions going forward. So a lot of times, like the platforms will give you a lot of security features, but creating like portable security features natively in the format is definitely a discussion that's kind of going on, particularly around encryption. Okay, now let's talk about v4. Okay, first I'll just quickly lay out the priorities. In the next slide, I kind of go more in detail about the actual proposals. But the idea is, how can we make commits faster? Okay, because nowadays, what do people really want to do, or do a lot of? Streaming. Okay, and Iceberg works phenomenally for batch. Streaming can be challenging because you're creating so many snapshots and you're creating a lot of files. Okay, sort of as was discussed during the keynote, you create all these files and then you want to run compaction. But if you're continuously streaming, how do I run compaction that doesn't collide with this? All these things are kind of challenging and tricky to figure out. I've heard quite a variety of different solutions on this problem. Like pretty much like I've gone to a few different like streaming vendor like conferences this year, and everyone kind of made their different Iceberg announcements and their different sort of ways of solving this problem. Super interesting stuff. But again, faster commits can help. Okay, smarter metadata. Right now, the metadata is mainly stored in Avro files. Okay, now oftentimes you may not be needing every column. You don't need to pull a whole row for sometimes to do your analysis. You may only want maybe just the column of stats. Okay, and you don't necessarily need these other columns within the metadata. So maybe we should store it in a columnar way. So there's a discussion about maybe storing the metadata as Parquet, okay, instead of as Avro. Greater portability. One of the things about Iceberg currently is all the paths for every file are absolute. So they'll say like S3 and say the specific location of the individual file. That's good, but what happens if you let's say you have a small table, and again, generally, you probably wouldn't necessarily put a very small table that you would email to someone in an Iceberg, but let's say you did, okay, and you wanted to email over that table, and you zipped it up, you zipped up the folder, and you sent it over, they wouldn't be able to query it because all the paths match your file system, not the file system they just downloaded the zip to. So there's discussions of how you can facilitate relative paths so that way you can make tables more portable. More useful is more like this for like disaster recovery, because what happens when you recover a bucket, but the bucket names where you recover the data is in a different bucket, and now all the paths point to another one. There's procedures to help rewrite the metadata currently, so you can do it, but it would be nice if you didn't have to go through all that extra trouble of spinning up a Spark cluster to rewrite metadata. That'd be good times. Okay, better indexing. So the idea is taking out, this is more like discussing like what else could go inside that Puffin file, what kind of indexes could be supported, what are the extensibility points for adding more indexes and more statistics. Wrong button. And then streamlined governance. In this case, always discussions around the catalog spec. So beyond just the table spec, you have the catalog spec. And the cool thing is that they're two separate things. So in this case, you don't have to wait for v4 for changes to the REST catalog spec. And that's another place where basically that's the standard for how catalogs talk to your tools. And that can be the avenue for creating a lot of standards regarding governance, regarding how you work with your tables. So there's a lot of conversations there. There's also a conversation about like the file of the actual underlying data files. So there's a proposal called the files, which I don't think, first of all, actually let me just list the proposals I did cover, and then I'll go to the ones that are sort of like the more ones that just came up really recently. So as I mentioned, single file commits. So the idea is like, how can you write metadata into one file? And then how do you determine when to do that and when not to do that? Parquet-based metadata, relative path support, richer column statistics, and again, more simplifying deletes and indexing. But also, other interesting things that are being discussed is like this thing called the Files API. So right now, generally, Iceberg supports ORC, Parquet, and Avro. But in practice, really, the format that all tools support is Parquet. Okay, like very few tools actually support, let's say, a reading of an Iceberg table that uses ORC or Avro. But right now, the support is built by building individual libraries for each format. Okay, so if you want to introduce like a third or a fourth or a fifth format, you then have to rewrite a lot of this logic again into the open source project. So there is a discussion right now about creating sort of an interface where a lot of like how the stats are collected from the files is done through an interface. So that way when you write it to the files, it's all done the same way. All you have to do is just write the plugin that actually gathers the data from the files. And that way you could theoretically in the future support some of these like new file formats that are being discussed. Like you've heard like Lance, Nimble, Vortex, all this kind of stuff. There's a lot of evolution at every level, always at every layer of the stack. So that's a discussion that's kind of going on. It's an interesting one. But yeah, so there's a lot of really interesting discussions going on. But that's where we're at right now. But of course, what did you see today? We announced Dremio Next Gen Cloud, which makes using Iceberg a lot easier. Now, I'm going to encourage you all to kind of get hands-on with it. So if you scan this, this is a tutorial that'll walk you through setting up sort of the free trial and trying out many of those new features.